Welcome to the Underhood Service podcast. This episode is presented by Mala, manufacturers of engine components, filters, and peripherals. Visit mala-aftermarket.com to learn more. And now, here's your host, Andrew Markell.
Welcome to the second edition of the Underhood Service podcast. Again, I'm Andrew Markell, Director of Content for Underhood Service. And today, we're talking about turbochargers. We're not talking about stuff that's coming in the future. We're talking about stuff that's coming to our bays now. 2019 is sort of a 10-year anniversary for turbocharger technology. If you really think about 2009, GM with the Ecotec, Ford with the EcoBoost, and also Hyundai with the Theta engine, and even Volkswagen, they started to put a lot more turbocharger vehicles on the road. Why? Well, they needed to meet a lot of the fuel mandates from the EPA. With these engines, you're typically dealing with a very small displacement to replace a larger displacement engine. So let's say there was a 2.2 liter engine that was in a portfolio of an auto manufacturer. This may be reduced down to now a 1.4 liter engine. Let's say a 5.4 liter or 5.3 liter V8 engine. Well, this is being replaced by a 3 liter or 3.5 liter twin turbocharged engine. They're doing this for efficiency. So what has made this possible 10 years ago, and it's even being modified and evolving as we speak right now? Well, it's better engine control systems. In other words, they're getting better at managing the boost pressure and managing essentially what's going on inside the combustion chamber itself. So back in the day, we probably remember some of the first turbocharged vehicles. I think it started with a Porsche 911. GM had it with the teeny tiny Chevy Nova. The biggest complaint about these vehicles was the turbo lag. For instance, let's say the Saab 900, if there was something wrong with the engine and it wasn't controlling this boost pressure, it would take a long time for that boost to build, and it felt really gutless down low. With today's turbocharging technology, it's almost the opposite. A lot of these small displacement turbocharged engines, which are now being direct injected, well, they're generating a lot of their power down low. I mean, the top of the torque curve for a lot of these engines, it's around 2,500 RPM. I mean, this is huge. I mean, a lot of those older turbocharged engines, the power did not start creeping in until 3,000, 4,000 RPM. So with these engines out there, they've been out there for 10 years and they've accumulated miles. They're out of warranty. So there are some service and maintenance issues with these turbocharged engines, but there's also some diagnostic issues you need to look at your shop and your own diagnostic process when diagnosing these vehicles. The most critical thing to remember about a turbocharged engine is oil. If you're maintaining one of these vehicles for a customer, you need to make sure that the right oil is being used. Because if the right oil is not being used, the turbocharger becomes damaged, and this typically damages the engine itself. So make sure you're looking at the grade of oil. And over the last decade or so, turbocharger engines, they're driving the new oil specifications. I'm talking about SM Plus you're starting to see on a lot of oil bottles right now, and also the upcoming spec of GF6. A lot of these were designed around turbocharged engines that were either port fuel injected or direct injected. These are some great oils because they're engineered around those. So we're talking higher temperatures, higher volatility numbers, better lubrication under certain conditions of high heat, just to make sure that those turbochargers can operate during the entire warranty period of the engine. So keep that in mind. Also, if you have a question about a turbocharged vehicle, look up in your service information, or if you have to, use the owner's manual in the glove compartment to see if there's a specific oil specification for that turbocharged engine. For example, let's talk about General Motors. They have a specification for their turbocharged engines, which is Dexos 1 Gen 2. It is critical that you follow that specification and use that oil for that vehicle. Chrysler, they have a very special MS specification for their turbocharged engines that can be either found anything from a Chrysler 200 to a Jeep vehicle to some of their Fiat line. But make sure that you're following that specification. Also, keep in mind Honda, they have their own oil specification for their turbocharged engine, which came out a couple years ago, that can be found inside the Civic, Accord, and some of their smaller SUVs. So look up the specification if you have any questions about the oil. So let's talk about the oil supply system on a turbocharged engine. Typically, you have a supply line that comes from the oil pump. This provides a flow of oil from the pump to the turbocharger center housing. A lot of these are affixed with a banjo bolt. Inside that banjo bolt, there might be a screen. If that screen is blocked by debris, which could be stuff just finding its way into the crankcase, stuff from bearings, even carbon and soot can build up on the face of that screen and restrict oil flow to that turbocharger. Some, including Subaru, even advise that you remove that screen. So if you do have a lubrication problem or an oil consumption problem with a turbocharged engine, make sure that you pull that banjo bolt and look at that screen. Some of them even have a screen inside the housing itself to prevent debris from making it into the bearings for the turbocharger. But make sure that you're looking at that screen to make sure there's no obstructions. Let's talk about the return line on the turbocharger. If the return line is obstructed, oil cannot flow through the turbocharger, even if it's under a lot of pressure from the oil pressure pump. One of the most likely culprits, it's crankcase ventilation systems. Mercedes-Benz, Audi, all have issues with this, to where you'll have a pressurized crankcase because you have a failed positive crankcase ventilation system, or what they like to call now an oil separator. These typically have a valve that allow crankcase gases to make its way into the intake tract to be burned off. Sometimes they are stuck shut. This causes high pressure inside the crankcase. This prevents oil from flowing from the oil return line. This can cause oiling issues with the turbocharger and eventually cause a failure of the turbocharger itself. So keep that in mind if you're diagnosing a turbocharger that has failed or is about to fail or is throwing a lot of oil either into the exhaust or compressor side of the system. Okay, quick tech tip about wastegates. Wastegates on most turbocharged engines have a specific preload on them. This can go both for electronically and also vacuum operated wastegates. There will be a turnbuckle on the arm that goes to the wastegate. If it's not properly adjusted, you can get some leaking of the exhaust pressure that turns the turbine into the regular exhaust, and this can cause low boost conditions if the preload is not done properly. Sometimes it can become a little bit out of whack after the car has undergone a lot of mileage, or there could be actually leaking from the valve itself on the exhaust side of the turbocharger housing. But sometimes pull the arm off with that clip. Do not lose the clip. I've always done this. Many a time has lost that clip. And check the preload and make sure that that wastegate is operating properly, and also the actuator that controls the wastegate is properly moving. Next, let's talk about bypass or diverter valves. It seems a trend has gone from a vacuum-operated diaphragm that's controlled by an electronic solenoid that controls the bypass from the intake side to the turbocharger itself and allows air to bypass to control the boost pressure. We're seeing a trend towards more of the electronic actuator. This is typically done with a duty cycle to open and close it at the proper time to control the pressure. These can fail over time, but most of all, they can leak and cause leaks in the boost pressure and a lower than normal boost pressure. When you're inspecting one of these, you might want to pull it off, look at it to see how it is sealing with the housing on the turbocharger. Also, this brings up another topic, checking for leaks in a turbocharger system. The best way to check for leaks on a turbocharged system is to have a smoke machine. But the thing to remember is you have to have the right smoke machine. Most smoke machines are built to diagnose evap problems, so they can only generate maybe 5 to 7 psi. Leaks on most turbocharged systems happen anywhere between 10 to 20 psi. In other words, that smoke machine cannot generate enough pressure to cause a leak. Also, if you're using one of these, keep in mind of what you're pressurizing. You could be pressurizing the intake track of the turbocharger itself. This shouldn't be done because technically that's not under pressure. You're really going to need to look at either the intake on the turbocharger itself and pressurize that, and what other valves in the system are pressurized to kind of give you a diagnosis of what is leaking. In some cases, you might want to pull off the hoses and just check the intercooler and the piping to the intake manifold itself. This way you can give a better diagnosis on what is actually leaking. It could be the intercooler, it could be the pipes, it could be the hoses that go between the pipes, but making sure that it's under pressure and there's smoke inside and isolating that part that you think might be leaking can lead to a faster diagnosis. Some cases, you're not even going to pressure check the turbocharger because it's a solid metal housing and very rarely will those leak. But you can use a smoke machine to check the diverter valve to make sure it's not leaking around the base. Okay, I've got a diagnostic tip for you. If you get a turbocharged vehicle in your shop and it has a code for boost pressure not at a sufficient level or high boost pressure or low boost pressure, the two data pins you need to focus on during a test drive are the desired boost pressure and the actual boost pressure. Take your scan tool, map those out, chart them on a graph so you could see how closely they match each other. They should be pretty close. In some cases, it may be a little bit before or a little bit after. In the case of a leak, you'll only see the actual boost pressure reach a certain level when the engine is commanding more of a boost pressure. But by looking at these two data pins, while you go for a test drive under different throttle and load conditions, you can assess if the turbocharging system is operating properly. In other words, you could see if the bypass valve or wastegate are leaking and it's not able to generate enough pressure by the actual boost pressure being lower than the desired boost pressure. By doing this, you can come up with an idea of what's going on in the system. It's not the final solution, but you're going to have a better idea of what component or what system to test next. But when you're diagnosing a direct fuel injected or port fuel injected turbocharged engine is to take a holistic approach. What am I talking about? Well, everything is designed to work together for the most efficient operation possible on that turbocharged engine. Simply put, the ignition system, the fuel injection system, they're working together with the bypass, wastegate, and also the variable valve timing system to maximize that boost pressure and to keep it in a range so the driver behind the wheel does not feel turbo lag. If one system is off, it's going to affect another one. For instance, if there's not enough fuel pressure, chances are it's not going to be able to generate enough boost. And it's the same way. If it's not generating enough boost, it's going to reduce the amount of fuel and you're going to get codes. Look at it as a complete system. Do not focus on just the turbocharger itself if you get a boost code. Make sure you're looking at everything else on the engine. It could be a cam and crank correlation thing. It could be a sluggish variable valve timing actuator that could be causing other problems with the system. Make sure that you're looking at the service information, particularly TSBs. General Motors and Ford have a lot of TSBs on this, including Acura with the RSX, and then they're even generating a lot of TSBs now around their new 1.4 turbocharged engine that you're finding in a lot of cars that are only 3 years old. But I guarantee you, within probably the next 4 to 5, they're going to be generating a lot of TSBs in regards to turbocharged engines. Another technology that you're going to have to diagnose on a lot of engines, and I'm talking about Acura with their RDX engine, and even BMW and Audi have these types of turbochargers. I'm talking about dual scroll turbochargers. This is on the exhaust side of the housing of the turbocharger. And what it is it's two different pathways for air to go through the turbocharger. In other words, these pathways come in at different angles of the turbocharger blades. So it's able to spin, let's say at low RPMs where the exhaust pressure is not as high as it should be, on a different part of the turbocharger and different geometry to help improve the pressure. So it's moving that turbocharger faster, so it's generating boost under, let's say, a cruising condition at 2,000 RPMs. And then, let's say when that driver decides to get on the freeway and they need to get up to speed very quickly, a flap or valve will open to channel air over the other part of the scroll of the turbocharger. And in some cases, it may operate either or channel or both at the same time. This helps to improve the control of the speed of the turbine, so it's generating the desired boost for the right engine conditions. So just keep that in mind that this is just one more actuator you should be looking for on the turbocharger housing. This is not the wastegate, it's the valve for the dual scroll turbocharger. Okay, let's talk about repair. A lot of these vehicles, well, they're now 10 years old. They have a lot of hoses either connecting the intercooler to the turbocharger, the intercooler to the intake manifold, that are starting to get a little bit crispy. In other words, they're not able to hold boost pressure anymore, and chances are they could fail under certain high boost conditions or even cause a small leak. We're going to start seeing a lot more of those as these turbocharged engines start to rack up the miles. The other failure we're starting to see a lot more on some of these higher mileage engines that may be 7, 8 to 10 years old, it's the vacuum lines that go to the actuators for the wastegate and also the bypass valve. Due to the higher underhood temperatures on some of these turbo engines, these lines can fail. They can crack or they fail to hold pressure, especially around those boots that hold it to the actuator itself. If it's not able to hold the right amount of vacuum or boost pressure, the leak will cause that actuator to operate slowly or not operate at all. And this could be a source of a lot of codes. The other thing we're starting to see is a lot of these diverter valves are starting to fail. I'm talking about the electromechanical side of it. When they do fail, well, they're no longer able to either bleed off the boost pressure or control the wastegate itself. You can test these with either a multimeter or a scope to make sure they're getting the right signal to them, to ensure that it's not the ECM that's the problem, it's the actual actuator itself. The other failure, well, it's the turbocharger itself. As we talked about before, these need the right amount of oil and the right grade and specification oil to properly operate. When these turbochargers do fail, it's typically because the oil, and they usually take the engine with it. If a turbocharger has play in it, typically what happens is it starts to spin, it hits its housing, and it damages the fins. When the fins are damaged, it's no longer able to generate enough boost. Then the seals start to leak. And when the seals start to leak, there's an oil consumption problem. And since most customers don't even realize they have a turbocharger underneath the hood, it starts consuming a lot of oil, and the customer will typically run the oil low and damage the engine itself. So it's critical that the customer is aware of what's underneath the hood, so they're not driving around with a check engine light that may be turbocharger system specific, that could be a ticking time bomb underneath the hood that could damage the whole engine itself. This has been seen a lot on the Hyundai Theta engine. What's happened is that the customer neglects the oil change, and either there's issues with the oil itself and the turbocharger fails, taking the entire engine with it. Hyundai, well, they introduced, this is kind of a neat concept, new dipsticks that increase the oil capacity of the engine. So in other words, if you get a Hyundai Theta engine in your shop, it even could be a Kia, you will notice the color of the dipstick. If you look at the dipstick, and if it's the normal yellow color, that means the vehicle has not been inspected for this engine replacement recall. If you actually manage to see the orange dipstick, it's a sign that that dipstick is a modified dipstick adding extra capacity to the oil pan. If you see one that is red, it's a sign that the engine has been replaced under the recall. Part of the failure of this, yes, it is the crankshaft and the deburring process that left debris inside the crankshaft itself, restricting the oil passage. But it's exacerbated by the turbo itself because the turbo quickly degrades the oil, and this led to a lot of the failures of these engines. So if you get a Hyundai in, check the color of the dipstick. Okay, let's wrap up this podcast here. So turbochargers, they're not a fad anymore. General Motors, Ford, Hyundai, Honda, and a lot of other manufacturers are using these engines in their engine lineup, so there's no avoiding them. So what do you need to do to service these vehicles? Well, first of all, look at your maintenance schedules at your shop. Make sure that you're carrying the proper oils in your inventory for these engines. Also, make sure that you know the service interval for those vehicles. It's not going to be 10,000, it's not going to be 7,000 miles. Make sure that you look up the proper service interval for the driving that the vehicle does in the field. Also, look at your tools. Make sure that you have a proper smoke machine that can generate enough pressure to pressurize the turbocharger system so you can check for leaks in hoses, intercoolers, and intake manifolds. But the most important thing is training. Always be training on turbochargers. I'm Andrew Markell, and thank you very much for listening to this podcast.
Thank you for listening. Be sure to subscribe to the Underhood Service podcast for more episodes. And visit us online at underhoodservice.com.